In the shadowed dawn of April 16th, 1947, a quiet port city in Texas City, Texas.
Besiege officials for word of missing loved one. Blast all but obliterates the city and turns the area into a sea of searing flame.
A tragedy etched as one of the deadliest industrial accidents in United States history. This is more than a tale of loss. It's a case study in disaster management, industrial safety, and a scientific quest that probes the very nature of reality. Could this explosion, this moment of chaos, hint at a collision not just of chemicals, but of multiverses? The story ignites with a single, fateful spark aboard the SS Grandcamp, a French-registered cargo ship resting in a harbor. Its holds brimming with approximately 2,300 tons of ammonium nitrate fertilizer, a lifeline meant to aid post-war agricultural recovery in Europe. Mingled with this volatile cargo were peanuts, tobacco, twine, bunker oil, and small arms ammunition. A perilous brew awaiting its moment. Around 8 o'clock in the morning, longshoremen toiling in the cargo hold caught the first wisp of smoke. A harbinger they tried to quell with a gallon jug of water and fire extinguishers, only to watch as dense smoke swelled unchecked. As the blaze grew, the ship's captain faced a crossroads. Fearing water would ruin his valuable load, he ordered the hatches sealed and the hold flooded with steam. A decision cloaked in hope yet shadowed by ignorance. This choice, meant to smother the fire, instead forged a deadly trap, revealing a critical vulnerability in crisis management. A fundamental lack of understanding regarding the properties of hazardous materials that can turn a developing crisis into a catastrophe. The firefighters who rushed to aid were equally unaware of the fertilizer's explosive potential, their efforts undermined by a prioritization of property preservation over safety, setting the stage for an escalation from shipboard fire to an unprecedented industrial explosion. Then, at 9:12 in the morning, the world trembled as the ammonium nitrate detonated with unimaginable force. A blast that erased the SS Grandcamp from existence, leveling the dock and industrial infrastructure within a 2,000-foot radius. This was no solitary thunderclap. It triggered a devastating chain reaction, igniting further explosions at a nearby Monsanto Chemical Company warehouse and setting ablaze the SS High Flyer. A second cargo ship, also carrying ammonium nitrate, docked approximately 600 feet away. 16 hours later, at 1:10 in the morning on April 17th, the High Flyer, adrift and consumed by flames, unleashed a second explosion, its power surpassing the first in the eyes of awestruck witnesses. The physical impact was a symphony of destruction. A 15-foot tsunami crashed onto the docks, flooding the area, while a seismic shockwave radiated outwards, felt as far as 250 miles away in Louisiana and registering on seismographs in Denver, Colorado. Massive pieces of shrapnel, including the Grandcamp's 1.5-ton anchor, were hurled up to 2 miles from the blast site, landing in homes and businesses across the city. Flaming debris from the explosions ignited numerous secondary fires in oil storage tanks and chemical plants, which burned for days, prolonging the crisis with relentless fury. The human toll was a wound that cut deep. Nearly 600 fatalities were officially recorded, with 405 identified and 63 remaining unidentified, their remains interred in a memorial cemetery. An additional 113 individuals were classified as missing, with no identifiable traces ever found, including many firefighters who were aboard the Grandcamp when it exploded. It is speculated that hundreds more, including visiting seamen and undocumented laborers, may have perished uncounted. Over 5,000 people sustained injuries, with 1,784 requiring hospitalization. The disaster also left more than 800 people orphaned or widowed. The Texas City Volunteer Fire Department suffered an almost complete loss, with 27 of its 28 members killed in the initial Grandcamp explosion. This devastating loss of first responders severely hampered immediate emergency efforts, which were further complicated by a telephone operator's strike that initially delayed coordination of rescue efforts. The economic damage was immense, estimated at $100 million in 1947, which equates to over $1 billion in 2023. Nearly 1,000 buildings were destroyed, including the Monsanto plant, which was completely flattened, killing 145 of its 450 workers. The seaport was devastated, countless businesses flattened or burned, and over 1,100 vehicles were damaged or obliterated. The destruction left thousands homeless as fires raged through the area. In the aftermath of the disaster, victims' families pursued legal action, leading to the first-ever class action lawsuit against the United States federal government under the newly enacted Federal Tort Claim Act. Although the victims ultimately lost their case at the Supreme Court, Congress later intervened, granting compensation totaling approximately $17 million to 1,394 claimants. A crucial and enduring legacy of the Texas City disaster was the fundamental overhaul of industrial safety regulations, particularly concerning the storage and handling of ammonium nitrate. New standards were implemented requiring cool temperatures and specialized containers for storage, prohibiting its storage near reactive materials like fuel oil or sulfur, discouraging long-distance travel, and greatly restricting overseas transport. These changes were a direct consequence of the detailed investigations that followed, which concluded that the conditions on the Grandcamp were conducive to the ammonium nitrate's reaction, even if the precise ignition source of the initial fire remained unidentified. Furthermore, the disaster underscored the critical need for a more proactive and centrally coordinated emergency response system. This led to the establishment of state emergency management offices and the formation of the Industrial Mutual Aid System in Texas City, a cooperative endeavor among local refineries to provide mutual assistance during disasters. This model of inter-industry cooperation subsequently spread nationwide. Later, the Occupational Safety and Health Act of 1970 and subsequent standards, such as hazard communication and hazardous waste operations and emergency response, were significantly influenced by the lessons learned from industrial tragedies like Texas City. The comprehensive historical accounts of the Texas City disaster consistently describe a chain of events rooted in the well-understood principles of chemistry and physics. Investigations into the incident, including those prompted by inquiries into unexplained events or paranormal accounts, have consistently yielded explanations that are entirely consistent with known physical processes. There is no documented evidence of anomalies or phenomena that defy scientific explanation. The unexplained aspects of the disaster primarily pertain to the difficulty in identifying all victims or pinpointing the exact initial ignition source, rather than any mysterious or supernatural occurrences. This robust body of evidence firmly establishes the Texas City disaster as a thoroughly investigated industrial catastrophe with clear, scientifically plausible causes and effects. Now let us lift our gaze to the infinite. Where the concept of a multiverse, a tapestry of multiple universes beyond our own, beckons with profound intellectual fascination, weaving through ancient philosophy and cutting-edge theoretical physics. Understanding the distinctions between these various interpretations is crucial for any rigorous discussion of parallel realities. While the notion of many worlds has roots in ancient Greek atomism and Stoicism, as well as early Buddhist philosophy around 100 AD, contemporary scientific interest in the multiverse arises from several prominent theories in modern physics. One of the most compelling theoretical underpinnings is inflation theory. This widely accepted cosmological model describes an epoch of extremely rapid, exponential expansion that occurred in the fleeting moments immediately after the Big Bang, approximately 13.8 billion years ago. According to inflation theory, the universe was permeated by an inherent energy that drove this super-rapid expansion. The theory suggests that regions where this inflationary expansion eventually slows down or ends can effectively pinch off to form distinct bubble universes. A critical implication of this model is that these bubble universes, including our own, are thought to continue expanding and remain fundamentally separated from one another by the vast, continuously inflating space between them, meaning they do not typically interact or collide. String theory offers another theoretical avenue for the multiverse. This framework attempts to unify general relativity, which describes gravity and large-scale structures, with quantum mechanics, which governs the behavior of matter at subatomic scales. String theory postulates that the universe's fundamental particles are not point-like, but rather tiny, vibrating strings existing in higher dimensions, typically 10 or 11. When combined with inflation theory, string theory suggests that different bubble universes could possess vastly different physical properties, including unique sets of particles, physical constants, and even different numbers of spatial dimensions. This provides a potential explanation for the fine-tuning problem. The observation that our universe's fundamental constants appear exquisitely calibrated for the emergence of life. If an infinite number of universes exist with varying physical laws, it becomes statistically probable that at least one, like ours, would be conducive to life. Finally, quantum mechanics contributes to multiverse concepts through the many worlds interpretation. This interpretation posits that for every quantum event with multiple possible outcomes, all outcomes actually occur, each in a separate, branching reality. This leads to a conceptual tree of universes, where each branch represents a distinct reality resulting from a different quantum choice. In these Level 3 universes, the fundamental laws of physics remain the same, but different quantum events lead to divergent realities. to bring structure to the diverse theoretical landscape of the multiverse. Physicists like Professor Max Tegmark of MIT have proposed classifications of parallel universes into distinct levels. Level 1 assumes an infinite universe where physical laws are constant. Identical or very similar universes exist simply by chance due to infinite possibilities, though they are replicas of our universe, but too far beyond our observable horizon to interact or detect. Level 2 arises from cosmic inflation, where different regions of space pinch off to form separate universes. Universes can have different physical constants, particle types, and dimensions, and are generally non-interacting. Level 3, based on quantum mechanics, sees every quantum event with multiple outcomes causing the universe to split into distinct branches. Universes are identical except for the specific quantum choices made, representing localized splits in reality. Level 4, the most extreme, posits other universes governed by entirely different physical laws and mathematical equations, representing all possible mathematical structures, encompassing every conceivable reality. These classifications help to delineate the vast conceptual differences within multiverse theories. A recent theoretical study, published in December 2023, introduces an intriguing hypothesis regarding the accelerated expansion of our universe. This phenomenon is conventionally attributed to dark energy, an enigmatic substance thought to permeate space. However, this new study proposes an alternative explanation. Our universe might be expanding at an accelerating rate because it is continuously merging with and absorbing smaller baby universes. This model also offers a novel perspective on cosmological inflation, suggesting that the super-rapid expansion in the early moments of our universe could have been caused by its absorption into a larger parent universe. Subsequently, this newly enlarged universe would continue to incorporate other baby universes. It is important to emphasize that this is a new theoretical study that develops a mathematical model to explore these hypothetical impacts on cosmic evolution. Its validity and ability to better describe the universe's expansion compared to the standard cosmological model are subject to future empirical validation through observations from advanced telescopes like Euclid and the James Webb Space Telescope. This theoretical merging of universes, as described by the baby universe hypothesis, is fundamentally distinct from the notion of a localized, destructive collision often depicted in popular culture. The theoretical framework describes a process occurring on a cosmological scale, influencing the overall volume and expansion rate of the universe, rather than a discrete, violent event capable of causing a terrestrial explosion. Furthermore, the prevailing scientific understanding, particularly from inflation theory, suggests that most parallel universes, especially the level 2 bubble universes, are thought to remain perpetually separated and non-interacting due to the continuous expansion of space between them. While the baby universe hypothesis introduces a form of interaction, it is a gradual, large-scale absorption process, not a sudden, impactful collision that would manifest as a localized catastrophe on Earth. The idea of multiple worlds is not solely a product of modern physics. It has deep roots in philosophical thought. Ancient Greek atomists, for instance, argued that the accidental collisions of atoms in an infinite void could give rise to an endless number of parallel worlds, some less perfect than our own. Early Buddhist philosophers around 100 AD also described a cosmology of many parallel worlds, each undergoing its own infinite cycle of creation and destruction. Medieval thinkers, such as the Persian theologian Al-Ghazali and the Andalusian philosopher Averroes, debated the contingency and necessity of our universe, with some postulating the existence of infinite worlds. In modern culture, the multiverse concept has permeated popular imagination, particularly in science fiction. Level 3 parallel universes, where alternate realities diverge based on different choices or quantum outcomes, are a common trope in movies and books. Films like Multiverse dramatically portray scenarios where parallel universes will collide, leading to dire consequences. While intellectually stimulating and creatively fertile, these fictional narratives often take significant liberties with scientific principles, depicting interactions that are not supported by current theoretical physics. It is crucial to distinguish between these imaginative explorations and the rigorous, evidence-based, or potentially evidence-based frameworks developed within scientific inquiry. The explanatory power of multiverse theories, particularly in addressing cosmological puzzles like the fine-tuning of our universe, often comes at the cost of direct empirical verifiability. Many theoretical models suggest that other universes would be beyond our observable horizon, making direct detection or interaction impossible with current means. While some theoretical avenues propose indirect evidence, such as subtle signatures in the cosmic microwave background or gravitational waves, these remain speculative and are actively being sought, underscoring the challenge of empirically confirming the multiverse hypothesis. Now, let us turn our gaze to the boldest question yet. Could the Texas City disaster of 1947 bear the imprint of a parallel universe collision? This inquiry demands a critical evaluation, weaving through established science, theoretical musings, and the allure of speculation. As detailed in our earlier chapters, the Texas City disaster is a meticulously documented historical event with a clear and scientifically understood etiology. The primary cause was the ignition and subsequent detonation of approximately 2,300 tons of ammonium nitrate fertilizer aboard the SS Grandcamp. The captain's decision to seal the Grandcamp's hatches and introduce steam, intending to smother the fire, inadvertently created the confined, high-temperature conditions necessary for the ammonium nitrate to reach its explosive threshold. The ensuing chain reaction, involving the Monsanto Chemical Company plant and the SS High Flyer, was a direct and predictable consequence of the initial blast's physical forces, including massive shockwaves, flying shrapnel, and widespread fires. Post-disaster investigations, conducted by teams of chemists, engineers, and transportation officials, concluded that the conditions aboard the ship were conducive to the ammonium nitrate's reaction, even if the precise initial ignition source remained elusive. The subsequent implementation of stringent new safety regulations for ammonium nitrate handling across the United States further demonstrates a clear, scientific understanding of the chemical hazards involved. The disaster scale, while immense, is entirely consistent with the known explosive properties of ammonium nitrate under specific, adverse conditions. The scientific understanding of parallel universes, as explored in our cosmic odyssey, does not support the notion of a localized destructive collision that could cause an event like the Texas City disaster. The prevailing cosmological theories, such as inflation theory, suggest that bubble universes are formed in a way that typically keeps them separated and non-interacting due to the continuous expansion of the space between them. The very mechanism of their formation implies a fundamental isolation. While a recent theoretical study proposes that our universe might be merging with baby universes to explain its accelerated expansion, this concept describes a gradual, large-scale cosmological process. This merging would affect the overall volume and expansion rate of our universe, manifesting as subtle, detectable signatures in the cosmic microwave background or gravitational waves. Such a process is fundamentally different from a sudden, violent impact capable of triggering a terrestrial explosion. It is a phenomenon on the grandest cosmic scales, not one that would cause a localized chemical detonation on Earth. There is no scientific evidence, historical record, or expert analysis within the provided body of knowledge that suggests any connection between the Texas City disaster and a parallel universe collision. The detailed accounts of the disaster consistently describe a series of events fully explainable by known physical and chemical principles. Inquiries into unexplained events or paranormal accounts related to the disaster consistently yield descriptions of the well-documented physical effects, such as the shockwave, shrapnel, and tidal wave, and the human impact. No anomalies or phenomena that fall outside the realm of known physics were reported or documented by the numerous investigators, rescue workers, and witnesses. Similarly, discussions around conspiracy theories related to the Texas City disaster focus on the factual details of the event and its aftermath, such as the legal battles or the handling of cargo, rather than suggesting any speculative or external causes. The only mention of a 1947 conspiracy theory in the provided information, the Roswell incident, is explicitly debunked and entirely unrelated to Texas City. The human tendency to seek extraordinary explanations for large-scale, traumatic events is a well-observed phenomenon, often manifesting in popular culture and informal discourse. However, the scientific and historical records for the Texas City disaster are remarkably consistent and comprehensive in their explanation of the event as a direct consequence of the known chemical properties of ammonium nitrate and the specific, unfortunate circumstances of its handling and the emergency response. The absence of any documented unexplained or paranormal elements in the extensive historical accounts is a significant finding, reinforcing that the disaster's origins are firmly rooted in terrestrial, industrial factors. The sheer scale and nature of the Texas City explosion, while devastating, are entirely consistent with the known explosive properties of ammonium nitrate under specific conditions of heat and confinement. The physics of chemical explosions are well understood and do not necessitate exotic or speculative explanations. It is paramount to maintain a clear distinction between scientific theories, which are built upon testable hypotheses and empirical evidence, or the potential for such evidence, and speculative narratives or fictional concepts. While multiverse theories represent a legitimate and exciting frontier in theoretical physics, they remain largely unproven by direct empirical observation. Furthermore, their conceptualization of interaction or merging operates at cosmological scales, vastly removed from localized terrestrial events. The idea of a collision causing a specific, contained explosion on Earth, such as the Texas City disaster, is a concept primarily explored within the realm of science fiction. There is no scientific basis within current theoretical frameworks to support such a localized and destructive interaction between universes. The Texas City disaster is a well-documented historical tragedy with clear, scientifically understood causes and consequences. Attributing it to a parallel universe collision would constitute a significant departure from established fact into unsubstantiated speculation, blurring the essential lines between rigorous scientific inquiry and imaginative storytelling. As our journey draws to a close, we stand at the threshold of understanding, where the echoes of the past meet the frontiers of the future. The Texas City disaster of 1947 stands as a profound historical tragedy, the causes and consequences of which have been meticulously documented and scientifically explained. The catastrophe was unequivocally the result of the explosion of ammonium nitrate, triggered by a fire and exacerbated by a critical misunderstanding of the chemical's properties and subsequent improper emergency response decisions. The immense human suffering and economic devastation stemmed directly from the physical forces unleashed by the explosions and subsequent fires, with no indication of anomalous or external phenomena. This disaster, while tragic, served as a painful but crucial catalyst for significant advancements in industrial safety regulations and emergency management protocols across the United States, leading to a more robust framework for handling hazardous materials and coordinating disaster response. The concept of parallel universes continues to captivate the scientific community and the public alike. It is a legitimate and vibrant area of theoretical physics, driven by complex and elegant theories such as cosmic inflation, string theory, and various interpretations of quantum mechanics. These theories offer potential solutions to some of the most profound cosmological puzzles, including the accelerated expansion of the universe and the apparent fine-tuning of physical constants that allow for life. However, it is essential to acknowledge that these are theoretical models, and while intellectually compelling, they largely remain unproven by direct empirical evidence. Furthermore, the theoretical conceptualization of interaction or merging between universes, as discussed in the baby universe hypothesis, is vastly different from the dramatic, localized, and destructive collision often portrayed in popular fiction. Scientific models generally posit that parallel universes, particularly those arising from inflation, remain separated and non-interacting. The inquiry into a potential connection between the Texas City disaster and a parallel universe collision highlights a broader challenge in public understanding of science: the ease with which complex scientific theories can be misinterpreted or conflated with fictional narratives. The detailed analysis presented herein demonstrates that the Texas City disaster has well-established, non-anomalous causes, and current scientific models of the multiverse do not support localized, destructive interactions that could account for such an event. To foster a more nuanced and accurate public understanding of scientific inquiry, the following recommendations are pertinent. Promote scientific literacy. It is crucial to emphasize the importance of distinguishing between established scientific facts, well-supported theories, speculative hypotheses, and purely fictional narratives. Educating the public on the methodologies of scientific investigation and the nature of evidence is fundamental. Encourage critical thinking. Individuals should be encouraged to approach information, especially claims that blend scientific concepts with unexplained or sensationalized events, with a critical and discerning mindset. Questioning the basis of claims and seeking corroborating evidence are essential skills. Focus on empirical evidence. Reiterate that scientific understanding progresses through rigorous observation, experimentation, and the development of testable hypotheses. While theoretical elegance is valued, the ultimate validation of scientific claims rests on empirical evidence. For events like the Texas City disaster, the overwhelming body of evidence points to known physical and chemical processes, rendering exotic explanations unnecessary and unsupported. Acknowledge intellectual curiosity. While it is necessary to address and correct unsubstantiated claims, it is equally important to recognize and validate the innate human curiosity that drives questions about the universe, its origins, and its mysteries. This curiosity, when channeled through the rigorous methodologies of scientific inquiry, remains a powerful engine for discovery and a cornerstone of human intellectual advancement. Understanding the limits of current scientific explanation is as vital as understanding its capabilities. Thank you for traversing this odyssey with us, a narrative crafted with care by our dedicated team. What do you believe lies at the heart of this disaster? Science or the whispers of the multiverse? Share your thoughts below. Subscribe to join our next quest and keep the flame of curiosity burning bright. Until we meet again, stay wondrous.